Today we're going to do for the first time an example in chapter 12, which is a little more complicated, but the book actually has some pity on you and doesn't really make you do the hardest part of it. We'll see that in a second. So let's share. Let's go. Give me 1 second, please. We're closing the door. Sorry about that. Let's see. Where were we? Oh, we were doing this. We were going to mail, and we were going to look for Demetra's question about chapter 12, number 4. Simulation and risk analysis. So let's click on it. Okay, so I think the best way to do this example is to, first of all, let me talk a little bit about it, because this chapter on simulations is not found in too many videos. Maybe there's one video about this. So in simulations, what we do is we have a complicated system where, for example, the life of how many cameras you need to buy for your photography company depends upon, in this case, 3 factors. How many pictures you take at a wedding, how many weddings you have each year, and finally, what's the average number of clicks before the camera breaks? Well, photos, okay? So with those 3, but each one of those things don't really have, not a fixed number, it varies. And if you try to calculate based on the average, you'll get an average answer if in fact you can actually figure it out analytically, but you won't really get a sense of how variable the answer is, because maybe you might be right like 50% of the time, but you want to sort of have some reassurance that you're right 90 or 95% of the time. So in order to do that, you do a simulation. You get the distribution of the relevant factors, in this case, those 3 things that I mentioned. You figure out how they're related, and then you have the computer pick random numbers to simulate this process. And doing this many, many times, like 1,000 times, let's say, and looking at the spread of the results, you can then say, well, 95% of the time I'm going to need, I don't know, 3 cameras per year, and that will impact on your business plan. So that's a very quick, of course, you can read about it in the textbook, online, but that's a quick idea of what's involved. So, and again, we're going to be doing simulations as part of the last 10% of the class grade. I'll be assigning simulations that more similar to this, but perhaps a little more straightforward. Okay, so let's begin. So in this case, we're given 3 major factors that influence how many cameras you're going to have to buy. And that depends on the number of wedding bookings per year, if you have 10 or 20 or 30 jobs a year. And we're told that follows what's called a triangular distribution, which in turn is generates a probability based on 3 numbers, the lowest, the highest, and the maximum, or most likely value, I should say. And then we also need to know how many clicks you could have per camera. So the average camera will die after 150,000 clicks or pictures, but that, of course, is just an average. Is a spread that's quantified by the standard deviation of 10,500. And finally, we have a different amount of photographs per wedding. Some have 2,000, some have 3,000, some have 1,000, and that number also determines how many cameras we're going to have to buy, because there's lots and lots of big weddings, then the camera's going to wear out more quickly. So again, we have a number, a mean, and a standard deviation of 300. Okay, so they want you to develop a simulation model doing it 50 times. And then, but that will become quite complicated, even though the book does in fact walk you through it. But at the end of the day, they give you the numbers that are relevant. So for most of the question, we just have to simply use these numbers that are the results of the simulation, but we don't have to actually generate them. But these statements over here are helping you walk through the steps to simulate them. But again, you don't have to do that, thank God. You just have to know where you would put in the data. So the book helps you organize it by saying that the 5 relevant variables, the shuttle life, how many clicks you can have. Secondly, how many weddings per year, how many photos per wedding, the average weddings per camera is really an outcome. We're going to try to calculate that. And that also is going to determine how many years we're going to be using a camera. So these are going to be put into cells B3, B4, B5, B6, and B8. So to make that concrete, I prepared the following small example where we have in B3 the shuttle life. Instead of using some really big number, I picked a small number, hypothetically like 1,000. How many weddings per year? How many photos per wedding? I figure smaller numbers might be easy to grasp. The average weddings per camera and the camera life. But, okay, so let's work it through. So let's assume the camera lasts for 1,000 clicks. And you have 100 photos per wedding. So you take 1,000 divided by 100 to result in 10 weddings per camera. In other words, you have 1,000 clicks, and you can go through 10 weddings. The first wedding, you're going to use 100. The second wedding, 200, 300, up to 1,000. So you can go through 10 weddings. Now, how do you calculate that? Well, you take B, I'm sorry, it's going to be B, the number that's found in B3, C3 really, and divide it by C5. C3 divided by C5. Okay? Now, keep that in mind for a moment, and that comes out to 10. But if you mess up, if the camera breaks after every 10 weddings, and you have 20 weddings per year, what fraction of the year until the camera dies? Well, it's 10 divided by 20. 10, in other words, you have 10, you're going to have, it's going to last half a year. Half a year, you'll have, the 10 camera will be used up. I'm sorry, your 10 weddings will be, the camera will die after 10 weddings, and that took half a year. And then the next, so the answer to the question, the camera life in years, is only going to be good for your business for half a year when you finished up 10 weddings. Now, putting that in terms of cells, which is what they want you to figure out, I put that in the cell here. So in order to calculate this number, you have to divide, again, it's really it's B3 divided by B5, 1,000 divided by 10. I'm trying to make this more concrete for you to understand why this is the right answer. And finally, in order to calculate the camera life in years, it's going to be B6 divided by B4. With that, having said that, let's make this smaller perhaps. Smaller. Smaller. Not what I wanted. Now let's look at the question. Okay, so I should also point out that we know that the, let me explain this RAND thing over here. To create this Monte Carlo simulation named after the casino in Monte Carlo, the shuttle life is randomly generated using this formula. You round to the nearest zero means whole number. You want the normal inverse, meaning you want a certain probability gives you what normal number. Again, I'm not going to be able to explain this totally coherently because it's quite complicated, but you don't have to do it, at least at this point. The inverse means, let's say, for example, we've done in chapters, earlier chapters about the normal distribution. I said, if somebody is, what's the probability somebody, data follows a bell-shaped curve with the average weight equal to 150 with a standard deviation of 10, what's going to be the probability of finding somebody with a weight less than, I don't know, 160 pounds? So you go to the StatCrunch calculator, or you change it into a z-score. But now we're doing the opposite. We need for this particular simulation, again, we don't need it because the book did it for us. But if you were going to do this, you would need to do what's called the opposite or the inverse. We know the probability and we know the probability and we're trying to figure out which number gives you that particular probability. That's what's called normal inverse. And in order to do that, we need to have what's called rand parenthesis, close parenthesis, which means the computer is going to pick for us a random number anywhere between 0 and 1, like 0.37, 0.56, 0.99, and then plug in for the first case, for the shuttle life, we're told the average is 150,000 clicks and a standard deviation of 10,500, and that's where those two numbers go. Likewise, we have to do a similar process for the number of photos per wedding. The average is 1950. We're told that somewhere. Where'd it go? 1950, and a standard deviation of 300. That's why these numbers go here. And finally, the formula for finding the average weddings per camera is B3 over B5. That's what I tried to demonstrate for you before. B3 over B5 average weddings per camera. And likewise, the camera life is B6 over B4, using this sequence that simply following the book's pattern. Okay, that was the hard part. All right, I'm going to put this aside. And now we have to calculate simply again, if you would follow that through in an Excel spreadsheet and work it through, you would generate the following numbers. But of course, everybody would generate different numbers. Let's put them into Excel and open the file. And these are the numbers, no title to it. And they want us to tell you the following statistics. What is the mean? What is the standard deviation? What is the minimum? What is the maximum? And finally, create a frequency distribution. Well, you know what? It's much easier to do this. I'll use this for the frequency distribution, but I'll use StatCrunch for all the other statistics, which are really easy in StatCrunch. Oh, we're not logged in. Let me log into StatCrunch. Okay, now we go back to here. Okay, back to open a StatCrunch. We go to Stat, Summary Stat, Column, R1. We can start playing around with it, but let's get all of them. Compute. Now we have what we have. We have the mean is 5.08, check. Standard deviation 1.17, check. Minimum 3.14, check. Maximum 8.46. And now we need to calculate the frequency distribution. For that, I believe Excel is better to do. We want categories from 1, how many ones were there, or how many between 0 and 1, 1 to 2, 2 to 3, up to 13 to 14. So we create the following bins, and we've done this in early chapters. It's just coming back, I hope, to you, as it did to me, 1 to 14, 1 to 14. We then go to data analysis. Let's make it bigger. Histogram. Okay. We want the input range will be B1 through B50. The bin range will be C1 through C14. The output could be any place, hit OK, and we have our answer. The numbers that are going to go here, how many between 000913. That's right. You know what? We don't need this anymore. We do need this. Need this. I can, let's say, let's put it in 0, 0, 0, I believe. 9, 13, 16, 10. 9, 13, 16, 10. 1, 1, and the rest are zeros. So let's talk about this for a minute, what this means. We now know that how many this is a simulation of camera life. So 9 out of, and they all add up to 50, right? Does it add up to 50? 22, 38, 48, 49, 50, right. So we did this 50 times. 9 out of 50, which is 18% of the time. 9 out of 50 is like 18 out of 100. Camera lasted 4 years. And sometimes it lasted 5 years. And sometimes 6 or 7. And most of it, but what's the minimum? And you might ask yourself, well, what's the most number of cameras I'm going to have to buy? Well, it doesn't seem to be too much less than 5 years, sometimes 4 years, but that's just like 18%, like 80% of the time it lasts more than 5 years. Anyway, that's how you interpret it. Let's see if I got it right. Got it right. I'm surprised. That's it. All right, guys. Good luck.